All right, I'm going to introduce our next speaker, Dr. Janine Higgins. Janine is a new addition to our department, but certainly not a new face on campus. She's professor of medicine in the division of technology, diabetes, and metabolism. And in the next 3 days, we'll formally start her role as our new vice chair of research. I'm not counting the days. Dr. Higgins has earned a PhD from the University of Sydney. She's a translational scientist in every sense of the term. She's worked on rodent models, pediatric models, and adult models, and has developed deep expertise in conducting preclinical and clinical research studies around the areas of nutrition and dietary interventions. She's been continuously funded by a number of grants, and she's here today to tell us about what we eat and whether it's fact or fiction. So, Janine, over to you.
Thanks, Matt. Thanks everyone for having me and making me feel welcome. Much faster than me doing it. Thank you. So I want to start at the end today because we often run out of time to adequately thank the people that do the work. If you have a great idea, you need a greater team than the idea to do the work. I want to thank my nutrition core and my collaborators. Archana Monday was in the nutrition core for many years until about 8 years ago. She now holds a job as a protocol specialist with the CPI. But whenever we're short-staffed and we need extra nutrition expertise, or we have a big project and we need to brainstorm, Archana comes and helps us. And some of you already know Archana's name because she is kind enough to do my calendar, which I could never be more grateful for. I don't know how she does it. Then we've got John Padilla, Dan Forjan, and our manager Tyson Martin, who's here today, and he's the one that makes it all happen and keeps it on track and keeps the team functioning as a high-functioning team. These three people cover 4 locations on campus and service 65 to 70 protocols simultaneously at all times. So they're a remarkable unit, and I couldn't do anything without them. And for this work, I also want to thank Drs. Edward Sazonov from the University of Alabama, who's an engineer, and Dr. Megan McCrory from Boston, who's another interventional nutritionist. She does the front end of the studies, and in Colorado, we do the back end. So this work isn't possible without any of these folks. I'm not going to go into too much detail about nutrition, just to tell you it's important. It's linked to loads of things, and it's linked to poorer or better outcomes once you have chronic disease. Public health efforts for decades have done a lot of messaging to try and get us to focus on what we eat for optimal health. None of this has worked, as you all know. And the diet and weight loss industry in 2021 was a $71 billion with a B dollar industry. Okay, billion. If you think about how much research funding we bring in here every year, we could use a piece of that pie, I think. But it's important. People care about it. People don't know what to do. And I think as nutritionists, we often confuse people. So I just want to give a brief example of 2 pieces of data. On the top blue line is United Nations data of dietary intake in the US over the years. I've plotted, and you can see why no one lets me play Pictionary, very messily, the NHANES data, which is what we normally use in the US. And you can see over the same period of time on the same scale, there's 1,000 kcal per day difference in intake. Does this give you confidence that we know what people eat? I don't think so. Why is this? Because we have terrible methods, terrible. You talk about predicting anything. We can't predict anything. We can't predict people's behavior. We certainly can't predict what they eat. So the validated methods we have available to us are 24-hour recall. So you set up with a participant or a patient to call them 3 times. Half the time they don't answer the phone. They don't have time to talk to you, so you have to call them back. You go through a lot of prompting with them to get them to remember what they ate yesterday. This obviously requires cognitive function that not everybody has or has time for. Then we have a food frequency questionnaire, which measures habitual intake, not what you're eating now, but what you ate either 1 month, over the last month, or the last 6 months of the timeframes for the adult surveys. This is a 240-page questionnaire. There is more than 1 question per page. Now, you also have to take into consideration when answering these questions, how often did you eat this over the last 6 months? Well, right now, as we go into fall, I've been eating a lot of fruit. But if you ask me this again in December, I'll have forgotten that I was eating a lot of fruit. So there's so much executive function and actual math sort of proportionalizing what you ate over the last 6 months. It's very difficult. You wouldn't answer every question because not everyone's going to eat every food. It's also very hard to represent a lot of ethnic and minority foods. So it may not be the best tool depending on what population you use. Then we have diet diaries or diet records where you either write them, you photograph them, and it's prospective. You do it on the day. Theoretically, do it as soon as you finish eating, although people forget. These are the most accurate. And when I say accurate, in validation studies, the most accurate tool we have is 0.6 to 0.82 maybe. So 60 to 80% accuracy. I don't think any of us would think that that's terrific, but it's sort of the most accurate tool we have. There's doubly labeled water, which is a biomarker, which I'm not going to talk about, because it actually measures energy expenditure, not dietary intake, and then we infer that dietary intake is equal to energy expenditure over a week or two if someone stays weight stable. Weigh yourself every day and tell me how often you weight stable. It doesn't happen, so we give a big range of what weight stable is and then equate it because that works for us. And obviously people try and use this in children who are growing. That's just a bad idea. They are not weight stable. So I'm going to quickly go over this and just point out in red that the problem with almost all of these methods is that they require the participants to do a lot of recall, which is difficult, but mostly they require participants to estimate portion sizes. No one in this room can do it. Tyson's probably the only person in this room who can do it. I can't do it. It takes 6 months to a year of training for a nutritionist who thinks about this every day to get good at it. So for me to hand you some materials and guides that say, this is half a cup is, the size of a golf ball, and and to think that you can do it well is quite frankly foolish. A lot of people don't cook or bake, which makes it even more difficult for them to estimate the volume of something. The guides that we give are two-dimensional, which doesn't help with a three-dimensional meal on your plate where you might have layers of rice and curry and veggies. It's very difficult. And so this misestimation alone can cause a difference of anywhere from 100 to 500 calories a day. It adds up really quickly. So it's an issue. We have terrible methods. Then there are DEI considerations, as I've briefly touched on for all of these. You have to be very literate, except for the 24-hour recall. If you have a lower socioeconomic status, I'll show some examples in a second, you might not relate to any of the objects that we tell you are a certain size. Cognitive function is incredibly important for people who have any kind of delay or any kind of forgetfulness can be difficult, let alone going through to clinical symptoms of cognitive delay. And culture, a lot of the methods we use do not provide to accommodate all the different foods people eat, the ways they eat them, or the examples we use are just not culturally appropriate. This is one that we used to use in the nutrition course, very widely used. So tennis ball and a golf ball. There's lots of people who have never played tennis or golf, who never have touched one of these things, so that's meaningless. My all-time favorite, the muffin liner, because you don't cook and you don't know how to estimate, so we'll give you something from the kitchen to help you estimate. Not to mention the fact that if you go to a very fancy bakery, a muffin liner is one of those big, tall things with the thick, it's not half a cup, people. And then deck of cards most people can relate to, but even dice. We're now saying something's 4 dice. A lot of people cannot spatially put things together and imagine what the volume is. We're not helping people here. So the Nutrition Corps actually did a community consult with the CCTSI Community Engagement and Research Corps, where some people from the community and some experts not in nutrition came and looked at our materials, told us that they were as terrible as we knew they were, which is why we did the consult, helped us develop many new materials that were much simpler, much more inclusive. And during this, we found what we use now, which is visualize your portion size, thanks to the Canadian Cancer Council. That is just much easier. We can use it with adults, we can use it with kids. It's very inclusive and representative. So that's my DI aside. Back to the top. So if we do the diet diary, which is, I've just said is the most accurate, there are 3 ways you can record. Old-fashioned pen and paper, my personal preference. A phone app, which could be recording things in words or from a drop-down, and photos, or maybe just drop-downs. Or a photographic food records where we need a before and after picture of everything that you eat. And the participant burden of both the manual and the phone app are very high. One of the problems with diaries is that we know they change eating behavior. I don't know if any of you have done these. Do it. It is abhorrent. You literally end up eating all packaged foods or the same thing every day, so you do not have to figure out what you are eating anymore, every little thing that's in there. And you actually stop snacking because you just don't want to record it. And we do use these for behavior change and weight loss for that reason. So if you go to the manual and phone app versions, you can see that we're still stuck with this problem of people estimating or getting a scale and measuring amounts. So we know this causes huge inaccuracies. But if we go to photographic diaries, what we do in effect is push that problem onto our nutritionists. It makes it very expensive, but it lets the experts do the work rather than you doing the work. So the participants love it. And we've been very successful with these. We were the first in children and one of the first in adults to look at photographic food records. And this shows energy intake, carbohydrate, fat, and protein intake. And the first panel is, this is concordance with a weighted food record. The first dot is the diary, and then there's two photo representations here. They're the same photographs analysed by separate nutritionists, showing that the concordance between separate nutritionists is quite good. And we didn't see any difference, but the participant burden was so much lower that we decided to run ahead with this even in children. When we do the same study in adults, we find that it's actually much more accurate than the diet diary. Where do we go from here? So there's a theme between Michael's talk and mine, because we decided that we didn't even want people to have to take photographs. The most common problem when you say to someone, take a before and after, picture, what do you think the most common problem with this is? You forget to take the after. So we have loads of before pictures, and we're missing about 20% of the after pictures, which doesn't help us at all. We're back where we started. So we decided that we can't even trust people to take pictures, and we need to eliminate the people part of it altogether, and we can do that using wearable technology. This is where it starts. Don't worry, it gets better. So we started with a collar that measures with a microphone that measures swallowing sounds, and a strain gauge behind the ear. This is where Dr. Sazonov comes in. He and his students did this. That measures chewing, and developing an algorithm for food intake, but by volume, which we can get very accurate at using chewing and swallowing. So we did 4 visits in a lab setting, about 4 weeks apart. 3 identical meals, which were to use to get the algorithm up and running. Nothing very sophisticated. To do any machine learning or advanced modeling, we need way more people and way more data. So we're just doing N-1 modeling. And then at the end, everyone had a validation meal. Choose something completely different that we haven't modeled on, different foods, and see how we do. And at each visit, we had a research assistant weigh all of the food. So that's the gold standard here. We had the PRA take the before and after meal picture so that it didn't get forgotten. And participants completed a standard written diet diary that they were extensively trained on at the first visit. And then we looked at the AIM model with chews and swallows. And in the first panel, you can see the difference between the weighed food record and the diet diary. In the second panel on the right, that is the photographic food analysis by My Nutrition Core. And at the bottom is the chews and swallows model using the N-1 algorithm. You can see that the photographic diet diary halved the limits of agreement, much more accurate. But the chews and swallows were even more accurate than our diet assessment using visual photographs. So the chews and swallows was working out really well. However, when we looked at accuracy versus precision, so between subject variation on the left and within subject variation on the right, you can see that the diet diary is terrible for everything, but the photo analysis the Nutrition Core does is great for both accuracy and precision. Sensor is super accurate, but not precise. And this is a problem because a lot of our studies are longitudinal. So they want to look at changes in eating behavior over time. So this is going to be super problematic, and it's something we've definitely been working on. So we're not monsters. We did not send people out in the world with a collar and a strain gauge and a big box behind their back. We worked on what we get people to wear. So we started out with this big white box that is so heavy on your glasses that will go like this. People still wore it. We just put it away over here. And it had a strain gauge that touched the temporalis muscle for chewing. It had an accelerometer, some internal circuitry with other components, and a camera right at the front here pointing down. We then went to the next model, which is in the middle here, and you can see that there's no strain gauge now. We went to an optical sensor instead of a strain gauge. We made it smaller. We gave it a stronger accelerometer and battery, and that's someone wearing it on the extreme right. Down bottom left, you can see where the optical sensor is instead of the strain gauge, how it looks on the glasses. And this model is about 33% smaller than the model above. So we're getting smaller, smarter, better, and we can send people out into the world with this. This is what it looks like for the nutrition team. The blue bars on the bottom left are when the chew sensor detects eating or drinking, any kind of that kind of behavior. It's really bad. We can't determine fingernail biting. It's really hard for us to use fingernail biters in our studies. And without that sensor, the nutritionist would have to look through 2,000 to 6,000 photos a day. So this way they can look around the eating episodes, check briefly if anything was missed, zoom in on any photo they want. On the right, the USDA databases with all the nutrient information are loaded. So we sent people out into the world for a free living study. It's almost exactly the same as the last study. It was 30 adults for 1 day only. The only difference between this study and the last study was that the images that my core used were from the AIM device, not from beautiful pictures that we gave instructions to take. So we had a series of photos now to choose from. How did this AIM do out in the real world? NIR is the number of eating incidents verified manually. Then there's the number detected by the sensor, the total, the true positives, the false negatives, and the false positives. The outcome of this is that the AIM has 97% accuracy for detecting food intake, but only 80% success rate because it does detect a lot of false positives. So once we go completely to a machine doing this, and Tyson can retire completely forever, those will really add up. So we've been working on making sure we don't have as many false positives. But if we look at the data now in free living, everything is topsy-turvy. So the weighed food records on the left, the table below tells you differences from the weighed food record method. The sensor is still great, the food diary is fine, but now the image analysis is by far the worst. Why? If you look at the top panel here, that is what we would see in a before and after food picture. People are told take it at a 45-degree angle. If you have a beverage in an opaque cup and you completely finish it, put a napkin down and turn it upside down. You know it was 100% consumed. If it's not upside down, we operationalize that we only code it as 50% consumed and so on. At the bottom is, at best, what our AIM images look like. We see food labels, we see what people are getting out of the fridge, we see them cooking, we can see what condiments are added, we can see them eating, and we can easily see an empty bowl. As we all know, life is not at best. In fact, most of the time it is not. This is often what we see. So if you look in the bottom right corner of the first panel, there's a hand going into a bag. Can any of you tell what they're eating? You would assume chips, that's what we thought. But then there's red, sticky, licked fingers. Does that look like flaming hot Cheetos? Because we see flaming hot Cheetos stuck fingers all the time. You'd be surprised. There's also 2 cups here in this first panel. Are they drinking one or both? Who knows? And then the next panel after the stuck fingers is nothing. So what do we enter here? And these are things we encounter all the time. So there's oftentimes you can't identify the food. The nutritionist misidentifies the food because of lighting or blurriness or whatever. Family style eating where people don't always put a set amount on their plate, they'll dig back in and just put things straight in their mouth. The nutritionist misestimation of portion size, yes, even nutritionists sometimes are not completely accurate. And surprisingly, there's not often, but about 6% of the time, there's no database option either for the food that we see consumed or for the amount. It'd be very hard for us to get that right. So where are we going from here? Obviously, we're always improving the algorithm. I say we, Edward's always making the device smaller and different. We have automated privacy features that are going to go into place so we don't see toilets or worse. I won't disturb your lunch. And we are about to undertake a just-in-time adaptive intervention for passively decreasing energy intake in women and men with obesity or overweight. And the way this works, they wear the device, we have an app on their cell phone. We're targeting fast eating and overeating, which are two things that we know are associated with excessive caloric intake. And we developed about 250 messages, things like, you seem to be eating very quickly. Try putting a fork down between bites. But if I told you that 7 times a day, you would turn me off. So we had to come up with lots and lots of messages. We had a PhD student on a supplement grant who actually went and did acceptability, feasibility, and likability of every message. And it turns out that some things where we were trying to be very impartial, people found really judgy. So we had to take those ones out and reword them. And so whenever the algorithm detects that you are eating too quickly or you're going to go over your calorie target for a meal, the app will say, you seem to be approaching your calorie target. Take a pause and see if you want to finish this meal. I think just very simple messages, and some of them are educational. So we actually have a behavioralist with us for that work. And my team is doing a great job of identifying and reducing sources of error for the nutritional analysis. I put this here to highlight, I've highlighted the team members' names in bold, and you can see some of the things we're working on. We've made Colorado the forefront of this nutritional analysis part from wearable devices. So, in summary, what we know about nutrition is probably perception or fiction. It's probably not truth. And it's not because people aren't truthful, it's just because we have terrible methods. We have no traditional methods that measure meal timing, meal structure, or eating behavior, but we know that to change dietary intake, we have to change behavior. We have been completely unsuccessful, and we've never had a tool before that can measure behavior and microstructure of a meal. We have that now. So I think that AIM and other passive capture devices are really magical and are going to lead us forward so that we can both qualitatively and quantitatively study dietary intake, because I don't believe anything I already know from the methods we already use. So that's me, and if you have questions.
I'll get it started. So first, I hope your device never comes to market because I can see this on my temple right now. Talk to me a little bit about, first of all, I didn't even know this was a problem. So it's interesting that you've discovered this problem in terms of how we measure this aspect. Talk to me a little bit about the compliance issue. So if the device is on your temple, you always have the opportunity to say, you know what, I'm just going to pull it off or not actually have it monitor me as much. Do you see that in your studies at all? Or because there's this question of the human behavior trying to thwart the technology aspects?
Human behavior will always thwart technology. What is it? 90% versus 100%. That 10% can make the technology not do what it's designed to do. We have varying success, but we've so far focused on a younger, healthier population. And we believe that when someone's receiving a benefit from the technology, compliance will increase. So we have very few participants that we didn't get 3 days of compliant wear time, which is a minimum of 8 hours and minimum of 2 meals. And again, even this is controversial, right? So the other nutritionist says, well, if they don't have 3 meals, that's ridiculous. And I said, no, there are days I'm busy at work and I'm pretty sure I only ate once that day. And it might have been a lot, and then I was full the rest of the day, and then I was busy and I forgot and it was too late to eat. And people say, no. I'm like, yeah. People we're weird. We all do different strange things, and we eat differently under stress, and that's why these measures that go over days or weeks are not helpful. Intake goes up, down, and all around. But compliance is a big issue, and we're really interested to see in this new free living study where people are getting a benefit if compliance will increase.
Other questions?
If not, I'm just going to tell people, if you ever want to do nutrition intake measurements, it's not as easy as you think. So please talk to Tyson and I, whether or not you want to use the core, about what methods might be most appropriate.
There's a question online.
Okay.
The online question says, has this or similar technology been used to understand alcohol consumption? same issues of understanding how much people drink.
No, but it does have utility there, and we have ideas about how it can be used for other kinds of compliance, pill taking, in aged care. Are people really eating? You know, you can't tell, and people start getting emaciated, and you're not sure why because they've had meals. So there's lots of uses of this that we haven't explored. What we're trying to do is get it small enough, non-invasive enough, and accurate enough, have our models be really accurate. Once we can develop enough devices to do a load of people and we're not relying on humans on the back end to do all this analysis, I think we can really branch out. Alcohol would be an easy one we could do right now.
It's great. Thank you very much.
Thanks, everybody.